Assalamu alaikum. In this video, I would like to explain two of the most important concepts in database. These are dependencies and normalization. And the two concepts are self-explanatory in the sense that dependency, it explains itself. Dependency means when something depends on another thing. In database, when an attribute or a group of attributes depend on another attribute. And normalization also, it is self-explanatory in the sense that it comes from the word normalize or normal. Normalization means make things normal. That means things are not normal and you like to make them normal. In the dependency, there are some issues, some problems. We will come across these issues like partial dependency and transitive dependency. We will explain them. But these two issues or these two problems can be eliminated or removed or cured by normalization. That means the problems created by dependencies will be solved by normalization. And to explain these two concepts, I would like to start with dependency. And the best way to actually explain dependency is to explain it through what we call dependency diagram. This is what we call a dependency diagram, in which you will see here, for example, 4 attributes of a relation or for a table. These are employee number, employee last name, employee first name, and employee date of birth. You will see that there is one attribute that is different in the color. This one, which is employee number. And there is an arrow coming from this attribute to other 3. That also explains that these 3 attributes, the employee last name, first name, and date of birth, are determined by employee number. In other words, the employee number determines the rest of the attributes in this relation. Because employee number here is a primary key. You see it is underlined and it is bold, and it is now known that it is a primary key. A primary key means a key that you uniquely identify the rest of the records. It is a unique identifier for the rest of the records. So this is a dependency diagram in which some attributes like this are determined by this attribute. Of course, sometimes a primary key can be more than one attribute, can be 2. Like this. This is the dependency diagram in which like 2 attributes, we call them composite key. These 2 attributes together, they make up the primary key, and together the 2 of them determine the rest of the attributes, that is project name and hours worked. So this is understandable that more than one attribute, like 2 or more, can determine also the rest of the records, in which we call them a composite key. Okay, but what is this down here? This is what we call partial dependency. Partial dependency means that part of the key determines other attributes. Why part of the key? Part of the key means not the whole key, only part of the key, only one of them. Now project code, in this example, project code determines project name. It is true that project name can be determined by both of them, but it is also true that only project code by itself can determine the project name. This is what we call partial dependency. So partial dependency simply when part of the key determines other attributes. or some other attributes like this one, for example, can be determined by only one of the primary keys components. In this example, the primary key component is project code. But project code by itself is not a primary key. It is called partial key because the primary key is these two together, employee number and project code. So now what you know what a partial dependency is, right? Partial dependency is when part of the key, like this one or this one, it doesn't matter. But in this example, we have project code now. In this example, project code determines project name. If there is an arrow coming from employee number to hours worked, for example, then we can say also that is a partial dependency, which is employee number determines hours worked, but we don't have in this example. There is another type of dependency called transitive dependency, in which a non-key attribute determines other attributes. So what is the difference between this and the previous one? This one, we have a student number, student last name, department code, and department name. Good. So what is the primary key for this relation? The primary key for this relation is student number, because we can see that there is an arrow coming from these three. That means these three, each one of them can be determined by what? By student number. This is understandable. But you will notice something else, which is department code can also determine department name. That means if I know department code, I can tell you the department name. In other words, the department name dependent on department code. So this is what we call transitive dependency. So again, transitive dependency when a non-key. Non-key means not a primary key and not part of the key. It is just an attribute, just same like in other attribute, like this one, department code, and it can determine this one. It can determine department name. This is what we call transitive dependency. So all these student attributes are dependent on the primary key, but also the department code determines department name, or we can say that department name is dependent on department code, which is a non-key attribute. So let me give you another bigger example. Look at this relation in which the attributes are represented by letters from A to K. But you will see that these three letters, A, B, C, in the beginning here are bold and underlined, in which we would like to say that this is a primary key, which is a composite key. Now it is composed of three attributes, not only one, not two, but three. A, B, C together, they make up the primary key. And this primary key, which is A, B, C, determine D, E, F, G, H, I, J, and K. This is understandable that a primary key which can be one attribute or two attributes or three attributes, in this case we call them composite key, can determine others. But what you notice also, if you look at the bottom of this diagram, you will see that there are two examples of partial dependency and two examples of transitive dependency. Where are the partial dependencies? The partial dependencies are these. A, attribute A, which is part of the key, can determine both J and K. So J and K can are now dependent on A. In other words, A determines these two, J and K. There is another example, which is this one, B and D. B determines D, such that D can be known if I know the value of what? Of B. This is also partial dependency. And now let us just reiterate the meaning of the partial dependency. The partial dependency when part of the key determine other attributes. So both A part of the key and B part of the key, and they both determine other attributes. In this case we call them partial dependencies. Also, there are two examples here of transitive dependency. Look at this too. E can determine what? Can determine G. Is E part of the key? No, it is just a normal attribute, which we call it non-key attribute. So when an key attribute like E determines an attribute like G, that means this is a transitive dependency. Again, you will find another example. Look at F. The attribute F determines both H and I. So H and I, these two attributes, can be determined also by F. What is F? Is it part of the key? No, it is not part of the key. These are the parts of the keys. So what is F? F just is a non-key. It's just a normal attribute. So again, when a non-key attribute determines other attributes like H and I, this is called transitive dependency. So this diagram has two partial dependencies, which is A to J and K and B to D, and has two examples of transitive dependency, which is E to G and F to H and I. So these dependencies should be removed. And this relation should be made normal through the process of normalization. The process of normalization is to divide a bigger table or a bigger relation into smaller ones, in which we can remove partial and transitive dependency. How to solve the dependency problem? Through this normalization. Again, what is a normalization? A normalization is a database design technique that organizes tables in a manner that reduces redundancy and dependency of data. Normalization simply when you divide a larger table into a smaller tables and then link these tables together through the relationship. The purpose of this normalization process is to eliminate the redundancy, redundant data, to ensure that data is stored logically. Because here, when you look at this one, since for example E can determine G, I don't think that we should keep it here. We should take E and G outside and make them a table by themselves. And since F can determine H and I, we can take also F, H and I to make them a table. And since A can determine J and F, J and K, we can also take them as a table. And also B and D, we can take them as a table. So we can make like 5 tables from here and create a relationship between these tables through the primary key foreign key relationship, like I will show you in a minute. The normalization is actually can be done very easily and logically through 3 different ways. Any relation, when I look at it like this one, we call it in the first normal form. This is the first normal form, which is usually is not desirable. Even the second normal form is not desirable. We have to be third normal form. So we take it from the first normal form to remove the partial dependency, and then to the third normal form to remove the transitive dependency. When I remove these two, when I remove the partial dependency and then leave the transitive dependency, this means I have taken this to the second normal form. And then when I remove the transitive dependency, that means I move this one to the third normal form. So first let us explain what is first normal form. We call it first normal form, or 1NF. 1NF stands for first normal form. So in the first normal form, all key attributes are defined. When you look at this relation here, this one also this is in the third normal form, in which there is no partial or transitive dependency. And this one also it is in the first normal form, because we have partial dependency. This one it is in the first normal form because we have partial and transitive dependency. Now I would like to show you this diagram here. This diagram in the first normal form because we have partial and transitive dependency. What is partial dependency? Partial dependency here. This one. Invoice number determines customer number. The whole relation, of course, I have invoice number and line number. This is a composite key, right? A composite key in which this composite key determines these three attributes, which is product code, product title, customer number, and line units, which is normal. If I don't see anything here like that, I will say this is in the third normal form. But since I have partial dependency and I have transitive dependency, so this diagram, it is in the first normal form. So we have partial dependency because invoice number can determine customer number, and if I know the invoice number, I can know the customer number. So this is redundancy. Why? Because customer number can be determined by both of them or can be determined by only one of them. So this is kind of redundancy. Again, this is redundancy, of course, because the transitive dependency in which product code determines product title, which is an unkey attribute, determines another attribute. Also, we can call it redundancy. Why? Because the product title can be determined by two things. Can be determined by both of them, by these two keys, which is a composite key, as we can see from this arrow, and also can be determined by what? By product code. So this is really a redundancy, and the process of normalization gets rid of what? Of these dependencies. Okay, now let us work on the first one. Let us remove the partial dependency, this one. How do we remove the partial dependency? We remove partial dependency by removing customer number from the list, putting it here down, and we will see that part of the key that determines it. What is the key that determines it? The part of the key that determines it is this invoice number. So we take it out, a copy of it. Of course, we don't remove it completely. We have to keep it there because it is a composite key determining the other attributes. But we make a copy of it here, and then we take the customer number completely from top, move it here, and that means I am removing the partial dependency. In this diagram, I have removed only the partial dependency, but I left the transitive dependency here. I can see that product code determines product title. And this diagram, we call it in the second normal form. Here, this is the second normal form because the second normal form simply means the design is in the transitive dependency, but there is no partial dependency. And here I see no partial dependency, but there is transitive dependency. Okay, what do I need to do? I need to get rid of this transitive dependency. To get rid of the transitive dependency, I should take it to the third normal form, which is 3NF. In the third normal form, I would like to get rid of the transitive dependency. What is the transitive dependency? I would like you to look at it here, product code and product title. So I would like to take them down, but I will leave a copy of the product code here so that I can create the relationship later. But I'm removing product title completely out and leaving a copy of product code with the original relation, like this. So product code is left here, but product title has been removed from the original table, and I have product code determines it. Product code determines it. So product code now is a primary key for this, as the previous invoice number was a primary key for the customer number when I remove the partial dependency. How do I create the relationship? I would like you to follow these green lines. When I left a copy of the invoice number here, that will make up part of the key and at the same time foreign key for this primary key. Now invoice number for this relation becomes a primary key, and it has a relationship with this invoice number in the original relation. And also here product code becomes the primary key for the product title, and it is a primary key, but it relates to the original relation by product code that has been left there as a copy of the same attribute. Now there is a relationship between the three relations, in which the original relation, now it is down to only 4 attributes. Two of them make up this invoice number and line number makes up the composite key and can determine product code and line numbers. And here product code determines product title, and the relationship between product code and product title here, in the sense that product code is a primary key and product code here in the first relation is a foreign key. And again, invoice number here is a primary key for this new relation, and it is part of the key for the first relation and also foreign key. And these two together they make up the composite key, but each one of them is part of the key and foreign key, part of the key and foreign key. So I made up my first relation, this one, into what? Into 3 relations, in which I have removed the partial dependency first, this one, then I have removed what? The transitive dependency, to make up these 3 relations and to create relationship between them. And now I can design them such that I have removed both redundancy and inconsistency between the attributes. So this is generally a concept that explains the normalization process, in which we actually fixed the issues created by the dependencies, the partial dependency and the transitive dependency. We consider another example in the next video to explain this concept in more details, and then we'll take it from there. Thank you.